Hello and welcome to the new episode of the Network and Cisco Packet Tracer tutorials for beginner. CIS is here, and in today's tutorial we are going to work on OSPF Stub area and OSPF totally stubby area. Before I explain what are those areas, it's better you see in action. How does it works? In today's topology, we have OSPF area 0, router 1, router 2, and router 3 are connected via multi-layer switch. This switch works as a connector between these routers only, no specific configuration on it. We have an OSPF area 25 between R2 and R5, and we have a RIP network between R3 and R4. There are two networks behind R1, which we are going to configure the loopback for them to represent those networks, two networks behind R3, two networks behind R5, and two networks in our RIP network. IP addressing is following the router number for easy understanding. So let's begin with basic configuration of the routers. You are quite familiar with this configuration if you follow the channel so far, so we do it very fast. So let's connect to our R1, go to privilege mode, global configuration mode, and let's configure it. So interface peak 0/0, which is connected to OSPF area 0. IP addressing is very simple. 10.0.0.0.1 represent router 1/24. No shot, so interface is up. Interface loopback 0, just configure the loopback 0 with the /32. Okay, let's just zoom in just in case. So we go to interface gig, set up the IP address, create one interface loopback, assign the IP address, and we are going to create these two networks. So we go to the loopback 1, and IP address will be 10.1.1/24, and we have another network. Use up arrow, it's much more easier and faster for us to do the configuration. Use show up interface brief. Let's review. Everything is up and running, sounds good. So we just come back to global configuration. Later we configure the OSPF. Let's configure the R2. Let's make some space. Go to CLI, press enter, enable the router, go to global config, and interface gig 0/0. IP address will be 10.0.0.255.255.255.0. Interface loopback 0. IP address is 222.255.255.255.255/2052. Okay, don't have any other configuration. Let's take a look at the config. IP address on a physical interface and loopback interface. So do show up interface brief. Okay, we didn't enable the interface, physical interface, so we go back to interface gig 0/0 and no shot as a best practice. Now everything is up and running. Very good. So we have one interface in this side, so interface gig 0/1, no shot. IP address is 10.25.0.2. This interface is between R2 and R1, so we use 25. Do show IP interface brief, double check. Okay, everything okay. Protocol is down because R5 is still down on the other side. So let's configure the R5, make it slightly bigger, go to CLI, enable global configuration mode, interface gig 0/0, no shot, interface is physically up, and 10.25.0.5, router 5/24. Here we go, basic configuration, quite familiar for you now. And we have an interface loopback 0. IP address is 555/32, and we have two loopback 1 and 2 also represent the network behind R5. So we're following a nice mapped IP addressing for that. And use of arrow, now your expert, do show IP interface brief. Okay, let's test the connectivity between R2 and R5. So we can ping R2. Yes, here we go. Don't have an issue, that's good. Up and running. Let's configure the R3 on this side. And here we go, R3. Very good. Enable global config interface peak 0/0, IP address in area 0, 10.0.0.3, represent R3, and new shot. We have one interface connected between R3 and R4. So we're going to interface peak 0/1, new shot. IP address is 10.34.0.3/24, and we have interface loopback 0, IP address 333/32, and we have interface loopback 1 to represent the network 10.3.1.3, and loopback 2, which is 10.3.2.3. Do show IP interface brief. Okay, everything looks okay. Let's take a closer look. We have an interface in area 0. We have a RIP connection to the router 4. Several networks create with the loopback. And finally, R4 got the one connection between R4 and R3. Let's configure that interface. Interface GW0/0, no shot. IP address is 10.34.0.4 and /24. So for here, do ping 10.34.0.3. So are we able to ping R3? Yes, good. And we create two networks behind this R4 interface loopback 1, which is represent 10.4.1.4/24, and finally interface loopback 2 with the IP address of 10.4.2.4/24. Do IP interface brief. Okay, things looks okay. Exit do show IP route. No routing except the connected interfaces. So let's configure RIP, router RIP, and version 2, no sorry, and network we have 10.34.0.0 as well as network 10.4.1.0, and here we go. So all networks are went to the RIP, show IP route. We are done with the R4. We advertise these three networks and go to R3 to configure the RIP. So git router RIP version 2. If you forget how to configure RIP, please go back to the tutorial for RIP. No other summary, and we have a network of 10.34.0.0. That's it. We just need the basic connectivity. Show IP route. Let's see what we have learned. Okay, very good. We learned some RIP routing. Here we go, which are the network behind R4 and YR4. That's what we are looking. Let's take a look. Show IP route RIP. Only specifically show the RIP network for us. Okay, very good. So now it's time to configure the OSPF. Let's go to R1 and run the router OSPF1, and we have a router ID of 1111. For this router, I set the router ID, but as you know, the loopback with the highest IP address automatically takes the router ID. So, but in this case, sometimes Cisco network, some devices consider this loopback higher interface, which is higher interface than 10.1.1, and automatically get the router ID for that. So to prevent that, I manually set the router ID for this router OSPF process 1. And let's advertise our network. Let's start with area 0, backbone area 00, /24, wildcard mask of 0.0.0.255, area 0. And let's advertise the behind the scenes network, which are technically our loopback interfaces. 1.0.0.0.255, area 0. And this time I use the up arrow easily. And here we go. Do show IP route. But don't have anything yet. No one is in OSPF routing. So we only have the connector. Let's go to our trees. Just behind the corner before we focus on a stub and totally stubby area and show you what's the difference. So router OSPF1 on our tree. Router ID known in this time. We advertise in area 0, 10.0.0.0.000.255 area 0. So we advertise our connected interface to area 0. Also add our network for this one. Okay, network 10.3.1.0, wildcard mask of /24 and area 0. Okay, the neighbor relationship has become full. And here we go. Let's take a closer look. So we have router OSPF, advertise the interface, advertise to our loopback 3.1 and 3.2. So now the adjacencies came up and we expect to see some routes. Here we go. We have a combination of OSPF. We learn about the network behind R1, why R1. This IP addressing is easily show you that where we are looking, and also we learn about the RIP from previous. We saw that we can learn about all those networks. Very nice. So back to R1. Let's check. Do show IP OSPF neighbor. At the moment we have one router which is a BDR, and okay, so loopback looks like get the router ID for R3. Anyway, show IP routes, and we have learned about the network behind R3, but still we don't have any idea about R4. So as we know, we need the redistribution which we learned on previous video. Let's go to R2 and do some router configuration. Router OSPF1, router ID just put 222, and let's advertise our network 10.0.0.0.0.0.255 area 0. Connect to the backbone, and now configure the area 25. So we have a network of 10.25.0.0/24. Just let me get rid of it. So you can see the command fully network 10.25, because now the neighborhood she was created 10.25.0.0.0.0.255 area 25. Here we go. Let's take a look at the commands. So we go to the router OSPF1, set the router ID, advertise to the backbone in area, and advertise 10.25 in area 25. Cool. Do show IP route. What we have, we learned some OSPF from router 1, which are network 10.1.1 and 10.1.2. Also, we learned about the networks behind R3. Okay, that's good. So now let's go to R5 and do the OSPF configuration. Router OSPF1, network 10.25.0.0, wildcard mask of /24 in area 25. So we advertise that network. Let's advertise 10.5.1.0.0.0.255 area 25. Okay. Relationships came up between R5 and R2. We can see that. And let's do advertise 10.5.2. And let's take a closer look. Router OSPF1, advertise this area 25 interface for the main interface as well as two of our loop. Okay, here. Okay. Nice. And let's see what we have. Show IP route. Okay, good. We learned some inter-area routing because area 25 and area 0 are connected. So we know about the network behind the router 1, router 3, all of them learn via router 2. This is a beauty of the stub area which is coming to the picture. Before I explain about the stub area, let's add some other configuration on R3. And we go to global config and redistribute to mutual redistribution between RIP and OSPF. In previous video, we learned how to do redistribution between the OSPF and EIGRP. Now we do redistribution between RIP and OSPF. So go to router OSPF 1, redistribute to RIP, and use your friendly command @ see what we have. And do the subnet. That's it. And let's take a look at the redistribution command, the RIP into the OSPF. Nice. And let's go out, go to router RIP, and do redistribution OSPF process ID 1, and you can set the metric. Let's put metric of 5. Okay, let's take a look. You can use the & and take the help for syntax. So now let's take a look at R1. See what R1 learned. Show IP route, and we have learned a lot of things. Let's take a look what we know now. Connected network, ignore them. We have a normal OSPF within the area 0 from network behind R3 via R3. We learn about the OSPF external 2, which is redistributed network. We know about network behind R4, which are 10.4.2 and 1, and both of them learn from R3. And we have some inter area which are network behind the R5. So we know that the R5 network is learned via R2. So from the R1 perspective, everything is clear, and this link is between R3 and R4, which is this link here. So clearly R1 have a quite visibility over this topology. Let's do some ping test. Let's ping network behind the R5, 10.5.1.5. Can ping. Let's do ping behind the R4, which is located in the RIP network, and we have full connectivity without an issue. Same story goes to R2. For sure, we have a full routing here. Also then show IP route. We know about the network behind R1. Learn it from R1. We know the network behind R3, these two. We learn it from R3. We learn the network behind R4 via redistribution from R3. And also we know network behind the R5, which is O only, OSPF, because they are in the same area, which is area 25. And finally, we learned about the network 10.34 between R3 and R4, which is distributed. So from R2 and R1 perspective, the configuration is the same. They can see the entire topology. Let's just, for sake of connectivity test, ping the network behind R4, and we can reach there. And finally, let's take a look at R5 network. Show IP routes. So now this result is before we do the redistribution, and now take a look what's happening if we did the redistribution. Very good. So now R5 also have a full visibility of the network. Some connected network, some inter-area network behind R1. We have a network behind R3. We learn via the redistribution, network behind R4. These are clearly. And finally, we know about the link between R3 and 4. But as you can see here, all these networks are learned via R2 only. So it takes a lot of space in our routing table. So we have almost more than enough. Let's count it: 1, 2, 3, 4, 5, 6, 7, 8 line for our routing table, very specific. But as you can see, this topology, from R5 perspective, we have only one exit point. So it doesn't really matter even if we have a default route on R5, we can have a one line of configuration in R5 and go out from this network. So it's not like R1 when we have a different kind of exit point. We want to reach, we can go to the R3. If we want to go network behind R5, we can take the R2. But from R5 perspective, we just consume a lot of space in our routing table. To solve it, OSPF got a solution for this. Let's do this configuration and see the difference. So just remember this. Let me do this. Show IP routes, OSPF, focus on OSPF only. Let's take a closer look from R5 perspective. That's nice. We can see clearly only OSPF. And here is clearly showing that only exit point is R2 from R5 perspective. You go to global config and go to router OSPF process, and for area 25 from R5 perspective, yes, you can use the question mark and see what we have. We have a stub, and that's it. You just press, and as you can see, the neighbor relationship goes down because one of the attributes in a hello packet is stub status of the packet in a router. So we go to bring up the routing, we have to go to R2, global config, under router OSPF1, we have to go to area 25, and this time also stop. So now, see what's going on. After a while, okay, we have the router go to the full relationship, and this is a command area 25 stop. Both apply on R2 and apply on R5. So now let's go back to R5, and we can see the adjacencies came up, and we can see do show IP routes OSPF. And as you can see here, we have a slight difference. Previously, we have two E2 kind of network, which represent connection to the R networks behind R4. But now, because we use the stub area, instead of having those lines, we have still inter area, but we don't have inter area receivable by the redistribution anymore. The router automatically creates one default route here and point it back to R2, because that's the only exit point from the R2 to reach to the network behind R4. We have another option also to reduce even the size of the routing table on R5. We go to R2 again, and this time we use the area 25 stop, but this time no summary. This creates the stubby area. So as you can see here, if we go back to R5 and use up arrow key, now our routing table size is reduced to only one default route. Say if you want to reach to any inter-area routing, you just go to the 10.25.0.2, which is IP address of R2. And the beauty is still we have a ping. For example, let's ping the network behind R1. Ping 10.1.1.1. We can ping that network. We can ping 2 network. Let's test the network behind R4. Ping.4.1.4. We have full connectivity, but the advantages of the stub area is a routing table is very short. In case you have only one exit point, you can do this configuration and reduce the process consumption and as a result of the reduce the size of your routing protocol. So I hope this video is informative for you. I'm going to upload more video on a near future for you guys. And if you find this video informative, please subscribe, share, and watch and learn. Thank you very much and see you soon.